So today's question is collecting numbers. So we're given an array that contains the numbers. It's still like the same question from before. We're given 1 to n exactly once. We want to collect all the numbers from 1 to n in increasing order. So each round I can go from left to right and collect as many numbers as possible. The only difference from the previous one is that now we can swap. And we can do M operations that swap. So that means, what that means is that we cannot do it every time. Just do this approach, call it M time from before. Just like do the swap and then call it, do the swap and then call it, because it won't work since it would exceed the amount of times because it's really inefficient. So then what we have to do is we have to store the array, somehow change the operation so that we just do a minimum amount of operation each time we do a swap because it would just be generic and then afterwards make that modification and then go on. So how we would do it is if we do a swap, the most we have to do compare from last time is that we just have to compare the one that's left and right of it, right? Because that number, whatever number we're changing, swapping, the number before and after will be affected. Other than that, nothing else would be affected. And on the other side, it's the same, the other number. So in total, we have 4 numbers that we have to look at and compare with. And it could be less than 4 because there might be repeats. If they're overlapping, then we might have some repeats. Or if they're at the boundary, then there might not be a element at that place. So we're going to use the set to avoid repetition, like duplicates of the same thing. And we just want to check if it's possible or not. So we start off with IOStream, vector, and set is a new thing because we want to avoid duplicates and set handles it very well. And then we want to include algorithm. Next, we go through main. We have the iOS base with Synchro Studio, scene.ty to make input faster. Same code as before. We have n and m. We input them, and it's one index is 1 based rather than 0 because it's easier to deal with. So we have a vector of x and a position. And then for I from 1 to n, including n, we would input our x, which is our value. Then we would just get the position of those, the value where they are at, and get that position. Next, we would have our initial rounds. This is still the same as before. So we just iterate it and count how many there are. Nothing new. And then what the new thing is that we have to process each swap operation. This part is a new addition from last time. So we have from k to 0 to m. So basically m times. We would have a and b, and we would input the swapping of the numbers. And then our value in VA and VB are the following. We put them in, we check their value from the array, pretty straightforward. And then we set up our set to avoid duplicates. So we check the 4 things that I talked about. The element that's 1 away from the element being swapped. So we check if it's valid. If it's valid, we put it in the set to check it. And that's what we do is we just do the check. For int of v and check vowels, basically the set we created, if the position is no longer in the order, then we would make the rounds decrease. Basically, this means that we would remove it since before it was in order, now it's no longer in order. Like before it was out of order, now it's in order. So then we don't need to do it once more. So then that's why we decrease the round. And then after we do that, we would want to swap it. So then we would actually do the swap. So then we would just swap the element and then update the positions. This is pretty straightforward. And then obviously in the end, because we swapped it, we want to double check that if we added any new rounds to it, right? If swapping would add anything to it. So then we would do the same thing from before, except we check that if it is this case, then we would make the rounds add up because it's a new thing, right? So then that's basically it. And then we would just output the rounds each round after we do a swap and we would return it. Okay, that's it for today. I think the major things from this one is just still taking away from the last one, knowing that we have the value and the position so that we get an log in algorithm. And then on top of that, when we have the swap, we have to think smart. And just rather than do it over again m times, we would have something of the form, just checking the original past one, and then we do just check four values, and that would just be four times that rather than in m times that, right? It's a much better algorithm. Okay, that's it for today.